Alright, hi everybody. This is Sentential Derivations, video number 3. If you're following along with the slideshows on Moodle, this is slideshow number 16. And in this video, we're going to do sections 4 and 5. As you can see, I've got some visitors with me. They're not going to stay and do the logic, but they did want to say hi. This is Lucy.
Hi.
And Alice.
Hi.
My daughters. Now they're going to go and play while we do some logic. So say bye.
Bye.
Alright. So, hope you enjoyed our guest appearances there. In the last video, we did some very simple derivations using these 4 rules here. 2 of them we called arrow out, a modus ponens and a modus tollens version. And the other one we called or out, which has 2 forms. It tells us how to eliminate, how to get something out of a formula that's got an or as its main connective. So now what I want to try to do is apply those same rules to a slightly more complicated argument, the one that you see above me here, and it's the last example in section 4 of slideshow number 16. And this is going to get us a chance to see how to use these bottom rules here, which we haven't seen yet. So we've got our argument there. The first thing we do in any derivation is we write down the premises with numbers by the side of them, and we write down PR for premise. So I'm going to do that now. All right, so we've got our premises written down there. After that, we want to write down a show line, that tells us what we're trying to derive or what we're trying to prove. In this case, not S, our conclusion. So we're going to write 5 and then show and not S. And remember, we don't put anything there right now because we haven't actually derived it. We're going to wait until we complete our proof to put anything there. Okay, so now we've got these 4 premises. We're trying to get not S. You might not see exactly how to get there, but the way you want to attack this is sort of look and see the patterns you have in your premises and see if any of those patterns allow you to apply any of these rules here. So the first thing you might notice is that if you look at the first 2 premises, P, arrow Q and not R, Q or not R, and P, that actually has the right form to use the modus ponens version of arrow out, because we've got something of the form A, arrow B, that whole thing is our B, and we've got A, so the rule says we can derive the B formula. So that's what I'm going to do first here. So underneath our show line, I'm going to write down, don't need the parentheses anymore, Q or not R, and that comes from lines 1 and 2 by our arrow out rule. Hopefully that makes sense. All right, what do we do next? Well, again, we just want to see which rules over there have the right form to apply to the premises and now the things we've derived here in our derivation. Excuse me. If you look here at line 3 and line 6, I hope you can see that we've got something of the right form to apply our or out rule, in particular this first version here. That is, we've got something of the form A or B, where our B is actually this whole not R. We've got the negation of A, and so or out says we can get B. That is, we can get not R. Let me explain just a little bit about why that is, because sometimes that confuses people. The idea here is that our A formula is Q. So up here, if that's our A, then we've got not A. We've got not Q. Our B formula in the rule is this whole thing, not R. And so the rule says you just get the B formula as the thing you've derived, and so we get the whole thing with the negation itself. That is not R. That's how that rule works. Now, we're not quite done with our derivation because we're trying to get not S and we don't yet have it. But if you look at line 4 here, it says if S, then R. That is S arrow R, and we've got not R. So look at arrow out the modus tollens version. It says if you've got A arrow B and not B, you can get not A. That is, if you've got an arrow and you've got the negation of the second thing, you can get the negation of the first thing. Well, we've got an arrow. We've got a negation of the second thing. So we can get the negation of the first thing. We can get not S here. So that's line 8, not S. And that comes from lines, oops, sorry, I forgot to write the line here. This last one comes from 4 and 7 by arrow out. But we forgot to write the notation here for line 7. And if you remember, that came from 3 and 6 by our OR out rule. So there we go. We're almost done. We've done all the hard work. That is, we've derived not S from our premises. We just have to finish up the proof. And so the first thing we do is we cancel our show line. We write a line through it. The next thing we do is we say what kind of derivation it is. We've only seen one kind of derivation so far, what we call direct derivation. So we write dd. And finally, we do this thing that, again, doesn't yet make sense, but we want to get in the habit of doing. We write a box around everything that comes underneath the canceled show line. And that's the end of our proof. All right, what I want to do now is talk about certain kinds of common mistakes you can make when going through these simple derivations, and that will be the end of this video. But I'm going to try to transfer on to looking through the slideshow. Okay, so before ending this video, I wanted to talk about some common mistakes that you might make when doing these proofs, before we get to some more examples. There's kind of two mistakes you might make. Our book calls them mistakes of the first kind and mistakes of the second kind. The first kind of mistake is when you mistake an invalid rule for a valid rule. That is, you use a rule that isn't actually a rule in our system, even though it looks like a rule or it looks similar to a rule. So all four of these in this box here, this red box, are actually not rules of our system. But they sort of look like it. So take the first one here, P arrow Q, Q, therefore P. That's not actually a rule. The real rule, the arrow out rule, the modus ponens version, says P arrow Q, and then P as a premise, and the conclusion is Q. It's been inverted here, and so if you were to appeal to a rule like this, or if you made a move like this, if you had something of the form P arrow Q, and then Q, and you wrote down P, that would be a mistake. It wouldn't actually be a rule of our system. This is also, this second one is also a mistake. Again, it's got the conclusion and the premise mixed up, and same for these two here. It's relatively easy to avoid this mistake as long as you're just careful in applying the rules, especially as you're learning them. The second kind of mistake is much more subtle and much more frustrating to make and much more common. It's when you use a form of a rule that actually is valid, but it doesn't actually correspond to a rule of our system. So let me again illustrate with the first one here. So this says not P arrow Q and not Q, therefore P. That's actually a valid argument. If you go from this first premise, this second premise to this conclusion, you do have a valid argument. But it's not a rule of our system. I'm going to just now shine up the correct rules and explain what's going on. So again, look at the first example here. The correct instance of the rule says if you know that not P arrow Q and you know that not Q, then you're entitled by modus tollens, that arrow out rule, you might want to be looking at that now. You're entitled by the modus tollens rule to write down the negation, the negation of the antecedent. But what's the negation of not P? Well, it's not P. That is, it says you're allowed to write down an extra negation in front of whatever happens to be in the antecedent. So the correct instance of the rule would be from not P arrow Q and not Q, you could derive not P. You're not allowed to directly go from those two premises to P itself. That's not what the rule says. Let's take a look at the second example here. The real rule says if you know that P arrow not Q, and you know that you have the negation of the consequent, that is, if you have the negation of what's right here, that is not Q, you can derive not P. But that doesn't mean that you can derive not P from Q and P arrow not Q alone. And a similar thing applies to these OR out rules here. This is a really important point to keep in mind. So if this is still confusing, maybe pause the video, look at the rule sheet, and really make sure before you go on that you understand why these rules in blue here are actually rules, but the rules in red are not. Now, a common thing students often say at this point is they say, oh, this seems annoying. After all, aren't these really, like, take these first examples, the first red one and the first blue one, aren't these really the same? After all, isn't P and not P just the same thing? That is, you might think this is sort of overly restrictive. P and not P just say the same thing. Aren't they the same? Well, in one sense they are, in one sense they aren't. It depends what you mean by the same as. P is logically equivalent to not P. So in that sense, they're the same formula. That is, they mean the same thing. But P is not the same formula as not P. After all, P itself only has one thing, just P, and not P has three things, two negations and the letter P. So if you want to change P to not P or vice versa, you're going to need a rule to do that. Because again, remember, we're trying to come up with a system of rules that just looks at the form of the sentences, not what they mean. Put another way, we'd like to be able to have rules that a mindless computer program could apply. And while we know that P and not P mean the same thing, they're not the same formula. So to change them from one to the other, we're going to need a rule, and in fact, we will have a rule eventually to do that. But right now, the important thing to note is that these are not the same formula, and so it doesn't always mean you can substitute one for the other in a derivation. That is, these are syntactic proofs. They only look at the form of the formulas, not what they mean. Okay, let me just give an illustration of how this plays out in a particular example, and then I've got some practice problems you can work on. So consider this argument. P arrow not Q, Q therefore not P. So we start off the proof, or the derivation, just as we always do. We write down the premises, and we annotate them with PR. Then we write down the show line. In this case, we're trying to show not P. Now you might be tempted at this point to do the following. Say not P follows from 1 and 2 by arrow out, the modus tollens version. After all, we've got P arrow not Q, we've got the opposite of Q here, therefore we can get the opposite of P. But that's wrong. If you look at the rule sheet says to apply the modus tollens version of arrow out, you have to have the negation of whatever is in the consequent of the conditional. And the negation of not Q is not Q. It's not just Q alone. And so that proof there is incorrect. In a bit, we'll see how we do the correct proof. The basic idea, to correct this proof, what you have to do is first change Q into the double negated Q, that is not Q, and then you can apply our arrow out rule to get not P. Again, we'll see that in some later videos. For now, I'll put up some practice problems here. I'm not going to go through these on the video, but I will try to post some answers to these so that you can try them yourselves and see how you do.